All right. Hey everyone, it's Miss Sabi. So I am creating the last video for this polynomials section. I just created the multiplication one, and just to make it seem like I didn't record these videos one after the next and make it seem like I have a life or something, I put on a headband so it looks like it's not the same day. So peep my bow. You guys think it's skibbity? Do you think I've got riz? Do you think it's giving 6-7 aura? Anyways, back to math. So video one was introducing you to polynomials, right? So how do we identify the different parts? How do we write these things in standard form? And how do we add and subtract polynomials, right? And combine like terms. In the second video, we covered multiplication involving algebra and went into polynomials. And now we are going to do division. Okay. So again, we learn these things after the exponent laws because we have to apply this exponent laws for these problems, for some of them. Okay. So for division, if ever you see something written like this with a division sign, I want you to turn it into a fraction. So this is almost like distribution or distributive property, but for division. So this polynomial, which is a trinomial, is going to be divided by this constant. So every term is going to be divided by 6. Okay. So again, it's like the distributive property, but we're like dividing everything by that thing. So we're going to rewrite it as a fraction. So I have 6y squared divided by 6. Okay, let me kind of, do I have space? Yeah, I'm about to say. So let me bring that down. So 6y squared divided by 6 plus 42x squared divided by 6 plus 12 divided by 6. Okay, so just as when we were multiplying, we multiplied the coefficients, we're going to divide the coefficients, or in this case, the constant. And then that's it for this one. So 6 divided by 6 is 1. So we have 1y squared. 42 divided by 6 is 7. So we have 7x squared. And then 12 divided by 6 is 2. So I don't need to write the 1. So I just have y squared plus 7x squared plus 2. And that's my final answer. So 6y squared plus 42x squared plus 12 divided by 6. This is your final answer. Now, you'll notice that in the second example, it's already written as a fraction, but now I'm going to kind of like distribute everything. So I'm going to write 6x to the power of 4 divided by 2x squared. So everything is going to be divided by that 2x squared. 22x cubed divided by 2x squared. And then I have 12x squared divided by 2x squared. Okay, so everything is lined up. Now you have to be aware, because we just did exponent laws, that these are like bases. So you are going to apply the quotient law when dealing with those. So you're going to apply the quotient law, which says when you have the same base, you subtract their exponents. So we're going to do the same thing as we did before. We're going to divide those coefficients. So 6 divided by 2 is 3. And then we're going to apply the exponent law for when we divide, which is the quotient law. So we subtract their exponents. 22 divided by 2 is 11. And then we have x, 3 minus 2. And then we have 12 divided by 2 is 6. And then we have 2 minus 2. So what are we left with? We are left with 3x squared plus 11x plus 6x to the power of 0. Remember the 0 identity. Anything to the power of 0 is equal to 1. So we are left with 3x squared plus 11x plus 6. Okay. So we're not doing a long division yet. That's a whole other thing. A long division, we would be doing, like, let's say a binomial going into a trinomial or something like that. Okay, so that's long division. We will tackle that. I already have a video about that if you want to see what that is, but we're not doing that right now. We're just doing the basics. So let's see if we can apply this to a geometry problem. What does that look like? All right. So find the algebraic expression of the area of a triangle with the base of 6x and the height of 3x plus 2. So we're going to always write what we are given. So what are we given? We know that it's a triangle that we're working with. Okay. We're looking for, so highlight, area of a triangle, base is 6x, height is 3x plus 2. Okay, so triangle, base is equal to 6x, height is equal to 3x plus 2. Remember, we draw if there's no picture. So that's that. The base is 6x and the height is 3x plus 2. So I write it like that. Okay, so there's my triangle. Let me just label it triangle ABC. All right, so we are looking for the area. It says that the area of a triangle is base times height divided by 2. So let's go ahead and solve. So let's go on the other side. I'll write solution. Set my solution. I'm looking for the area. Area is equal to base times height divided by 2. I will substitute and solve. So my area is equal to, my base was 6x, and my height was 3x plus 2. And the area of a triangle is base times height divided by 2, because it's basically half of a square, or whatever, half of a quadrilateral, no, rhombus. All right, so we're going to do order of operations. I'm going to do the distributive property first. I'm going to do what comes first. So 6x times 3x, 18x squared. 6x times 2 is 12x. And then I'm going to divide that by 2. So remember, when we do that, everything is being divided by that 2. Like this. So the area is equal to 9x squared. So I forgot my 2. Plus 6x. Okay, so in the next section, we're going to learn how to factor, because I can actually factor this. I can take out the greatest common factor between those two terms. That is something that we will do shortly. So that is the answer to this one. Yes, we should write it in a sentence form, but I don't have space. Yes, we do have space. Let's not cut corners. Let's not be lazy. The area of the triangle is represented, right, because it's an algebraic expression, by the algebraic expression, which is, oh, where did it go? 9x squared plus 6x. Okay, so 9x squared plus 6x. That does not even look like a squared. I shall fix that. Okay. So here's the second problem. A rectangular garden has a perimeter of 12x plus 20. Okay, if the length of the garden is 4x plus 3, what is its width? What is its width? Okay, so not sure how to solve this one yet, but I am going to write down what I'm given and draw a picture to make sense of it. So what am I given? I have a rectangle. Very important to talk about what shape you have, because every shape has its own little formulas. So I am dealing with a rectangle. Its perimeter is equal to 12x plus 20. Its length is equal to 4x plus 3. What is its width? What is its width? Okay. So let me draw this rectangle. So I know the length, 4x plus 3. I know the perimeter. The width I don't know. So what's my solution to this? Let's try something out. So what's the formula for perimeter? So perimeter is equal to 2 times the length plus 2 times the width. Why? Because you have an L here, so 2 L's, and then you have a W here, W here. You add them up. That's what perimeter is. That is what we have. So let's look, and even if you're not sure what's going on yet, let's just plug in what we have. So we know what the perimeter is represented by, so we can substitute that in. So I have 12x plus 20. I know my length because they tell me that in the problem. So that's 4x plus 3. I don't know the width. So I'm going to leave that as 2w. Order of operations, BEM DAS, brackets, right? So I have brackets here. There's nothing I can do in it, but I know that I can do distributive property. So for now, I have 12x plus 20. Distributive property says 2 times 4x is 8x. 2 times 3 is 6. And then I have this plus 2w. Okay, so I want to isolate this w because I'm trying to find width. So I got to move everything away because that's what isolation means. When something is isolated, it's by itself. So I'm going to move everything away. When I move them away over the equal sign, they change signs. So if it was a positive 8x, now it's a negative 8x. The positive 6 becomes negative 6. And then I have 2w on that side. Okay, so I'm going to see if I can simplify some things first. So is there anything I combine? I can combine. Certainly there is. So 12x minus 8x is 4x. 20 minus 6 is 14. Right? And then I have is equal to 2w. Now, how do I isolate that w? Remember, if I want to get the w alone, I want it to equal 1. I got to divide by the coefficient. So I'm going to divide by 2. And what I do to one side, I have to do to the other. So what I end up with is 4x over 2 minus 14 over 2 is equal to w. So what do I have? I have 2x minus 7 is equal to w. So let's see what I have here. Just make sure that it's done right. Yep. So now I have the width. The width is equal to, so I can put that in on my picture, 2x minus 7. Now, if they ask me, what is the algebraic expression that represents the area of this rectangle, That could have been the question. I would have had to do all these steps to find out the width. And then what will we do? So let's be fun. I know you're probably mad. And figure out what the area is. Let's just humor ourselves. Figure out what the area is. Okay, so what would the area be? So your area of a rectangle is equal to length times width. This is my length. That's my width. So I just plug them into the formula, 4x plus 3 and 2x minus 7. And then I would apply FOIL. Okay, so I would distribute, right? So it's like a double distribution. So then I have area is equal to 4x times 2x plus 4x times negative 7 plus 3 by 2x plus 3 by negative 7. And then let's simplify that. 4x times 2x is 8x squared. Don't forget your product law. 7 times 4, negative 7 times 4 is negative 28. So negative 28x. 3 times 2x is 6x. And 3 times negative 7 is negative 21. Area is equal to 8x squared. 28. Is that plus 6 or minus 6? 28 plus 6. Is that negative 22? I think so. 6 minus it? Yeah, I guess so. Yep, 22. Okay. And then we have negative 21. So let's just make sure we have 8x squared, negative 28x plus 6x, and negative 7 times 3, negative 21. So that is the area, right? So that could have been the question. What is the area? And then we'd have to do all those steps to get to here because we would have needed the width, right? So we used the perimeter to find the width, the perimeter and the length to find the width. And then here we are. So that is the division piece. Now we are going to be looking at factoring using the greatest common factor. So there are a whole bunch of techniques for factoring. Taking out the GCF is the first thing that you learn. You learned how to work with greatest common factors since elementary school. This is a thing that you've been doing. But now we're going to apply it to algebra, which is a little bit more involved. So hold on for the ride. Okie dokie. So factoring using greatest common factors. So what is the greatest common factor when you have multiple numbers or digits or terms? The greatest common factor is the biggest number that you can divide all of the numbers by and still get a whole number, right? So, you know, we did number sets in the beginning of the year. All of this stuff is tied in, right? So again, what is the biggest number that you can divide all of these things by and still get a whole number? So sometimes you're asked to factor and simplify, right? And then factor your final answer. So if you can't see right away, like right away when I look at this, I'm like, oh, I can take out a 4. But that's because I just know I'm used to doing this. But if you are not used to doing this and you're looking for a GCF, just factor what you have into like factor trees. So this is 4, then you have n squared. This is n times n. So I'm just doing a factor tree, but with algebra, which is something that you're not used to. So how do we factor the 20n? Well, the 20n, we can say n times 20. How do I break down the 20? 5 times 4. And then the 4 can be further broken down into 2 and 2. So here are my prime factors. So I can write down my prime factors. I have 5, and then I have 2, 2, sorry. This is crazy. This should have been broken down to 2 and 2. That is not a prime factor. Let's fix that. So this is 2, 2. Okay. Now let's look at the 16. How do I break down the 16? Well, 16 can be broken down 4 times 4. And then these are 2, 2, 2. So we have 2 times 2 times 2 times 2. These are the prime factors. So now you're going to look. What is the greatest thing they have in common? Well, the greatest thing that they all have in common is 2 times 2. Okay, so again, greatest thing they have in common, 2 times 2. This one has a 2 times 2. This one also has a 2 times 2, which is 4. So then that means the GCF of these terms is 4. So what that means is this, if I want to factor this and take out the GCF, I'm going to divide this whole thing by the GCF. So everything is going to be divided by 4. So let's put that on the outside. So you put the GCF on the outside and you carry on. So I'll do that after. So you do the division. So 4n squared over 4 plus 20n over 4 plus 16 over 4. So I'm going to write the GCF, which is the thing that I've been dividing by. I'm going to write that on the outside of the brackets. And then I'm going to write the quotient inside the brackets. So remember, the quotient is your answer when you divide. So what is the answer? So 4n squared divided by 4 is just n squared. 20n divided by 4 is 5n. And 16 divided by 4 is 4. So this is this number, this polynomial, this is it factored. If you wanted to check to see if you did this correctly, if you factored it correctly, just do the math, do the distributive property, do 4 times n squared, 4 times 5n, and you should get what you originally started with. 4n squared plus 20n plus 16. So that means we factored it correctly because we got what we originally started with. Okay, let's look at these other ones. So what do we have going on over here? So I am looking to factor 25mn and 5m squared n squared. So I'm going to factor them down to their prime factors. So this is m times n. So it's 25. The 25 is broken down to 5, 5. So prime factors for this is 5, 5, m, n. So remember what prime factors are. When I multiply these all together, I should get the thing that I started with. Okay, now let's factor the 5m squared n squared. So breaks down to this, m squared n squared. Then what is this factor out to be? Well, m times n times n times n. So this is 5 times m times n times n times n. So these are the factors. So what do they have in common? Let's look. Well, the greatest thing they have in common, they both have 1 5. They both have in common 1 m and 1 n. That's the greatest that they, sorry, not n, and 1 m. Okay, so the greatest common factor, the GCF, is 5mn. So now we got to divide this binomial by the GCF. Our GCF is 5mn. not 5m squared, 5mn. So what does that mean? I'm going to have to divide 25mn by 5mn, and then the 5m squared n squared divided by the 5mn. So these cancel out. 25 divided by 5 is 5, and then 5 divided by 5 is 1, and then we're going to do exponent laws. So we have 2 minus 1, 2 minus 1. So remembering the GCF was 5mn, right? So that's what I took out. And then now I'm going to write the quotient in the brackets, which is 5 plus mn. So this is it factored. If I checked it back and see to make sure I get this, 5mn times 5 is 25mn, which is that. And then we have 5 times nn, so that would be m squared, n squared. So that is your factored answer. I'm going to give these a have a lot, but I won't do all. Okay. What about this one? How do I factor out the GCF? Let me move this down. So let's look at what 18a squared breaks down to. So I'm not going to do a factor tree. I'm just going to, so 18a squared b, this is 9 times 2, and then we're going to say times a times b. This breaks down to 3 times 3. So what is that? 3 times 2 times a times b. So that's the 18a squared. That's it factored. Okay, so I'm gonna put that like that. Now let's factor the 24ab squared. So I have 24, and then that is ab squared. So I know that I can just write that out. This is like easier to do that. So ab squared means I have 1a, 2 b's. Sorry, this is not for 24. And then my 24 can be broken down into 3 times 8, 4 times 2, 2 times 2. So let me highlight my prime factors. Okay, let's write them out. So 2, not like that pen. So then we have 2 times 2 times 2 times 3 times a times b times b. Now let's look and see what they have in common, the greatest thing they have in common. So they both have 1, 3 at least. Okay. They both have 1, 2. They have an A and they have a B. So if I put that all together, what's the greatest common factor? 3 times 2 times A times B. So that's 6AB is the GCF. Okay, so 6AB. So that means I'm going to be dividing this thing by 6AB. Okay, so each thing is going to be divided by 6AB. So we have 18a squared b divided by 6ab minus 24ab squared divided by 6ab. So what is that equal to? So I'm writing my GCF on the outside, and I'm going to write the quotient inside. So 18 divided by 6 is 3. Then we apply the exponent laws. So a2 minus 1, and then b 1 minus 1 is 0. So these actually cancel out, and we know that that's going to be 1. Okay. And what do we have going on here? So 24 divided by 6 is -4. The a's cancel out. b2 minus 1, b. So final answer, 6AB by 3A minus 4B. Right? So then that would be 20, that would be 18A squared B, correct, when I multiply it back. So here, 18A squared B, and then this one is 24AB squared, which is this, negative 24AB squared. All right, quickly, I can see what this is without even doing a factor tree. If I take out a negative 9x squared, then what I'm left with in the brackets is a positive 1 and positive 3y. If I want to check that back, so negative 9x squared times 1, 9x squared. Negative 9x squared times 3, 27x squared y. Okay, so I'm able to see those things right away. Okay, what about 48 mn? Okay, so for sure the biggest of the variables that I can take out is the mn. I know that. Now I need to find what is the GCF with 78, 60, and 48. So let's see, 78, it is a even number. So let's say, what is 78 divided by 2? 39. So I can probably just take out a 2. So the GCF is 2mn. So if I take out 2mn, then what I'm left is 24, right? And then if I divide this 78m squared by the 2mn, that is positive 39mn. And then I have this 60, so 60m cubed n cubed divided by, so my GCF is 2mn, so that is 30. Okay, so 30, and what else can we do? So 30, and then m cubed minus m squared, n cubed minus n is n squared. Okay, now you need to check again. Is there something that I can still divide by? So let's see. If you look closely, so I just trial and error without doing my factor tree. These can all still be divided by 3. So I need to take out a 3. 2mn times 3. So I'm dividing everything by 3, which is 8, plus 13mn divided by 3 plus 10m squared n squared. So the final answer of the GCF is 6mn, because I'm going to do the 3 times 2. 6mn times 8 plus 13mn plus 10m squared n squared. So let's check that back to make sure we did it correctly. So now this can't be reduced anymore. So 6mn times 8 is 48mn. 6mn times 13 is 78m squared n squared. 6mn times 10m squared is 60m cubed n cubed. So this is your final factored answer. So that was factoring by taking out the GCF. There are other methods of factoring that will be for another day. I think this was enough for you and for me. Like, it's not easy talking by myself to myself. Okay, I hope you liked my headband. Remember, this is a 3-part series. First one, we looked at introductions to polynomials. How do we write things in standard form? How do we add and subtract polynomials? The second video is multiplying algebraic expressions. Third video and the final of this section is dividing polynomials. And of course, GCFs, taking out a GCF, that kind of factoring involves dividing. So that's why I did them together. So I hope these videos are helpful. I hope that you use them well before a test. Okay, so I hope you use them to help you clarify things because these are basics. If you don't know the basics, then when it gets more complex, you're going to have a hard time. So lock down the basics, lock in, and it's not that hard once you lock in the basics. You're just going to be able to apply the basics to something bigger. It's not that bad, but you have to stay on top of it. And please make sure you're constructing your memory aid before, right? Not right before a test. Make sure you're using a memory aid every day so that when you get to the test, you know how to use your memory aid. You're familiar with what's on it. When you make a memory aid right before the test, it's like this foreign map that you don't know how to read yet. And you take all this time looking for the stuff you need. Whereas if you've been using your own memory aid to complete your homework, if you've been using it during class, by the time you get to the test, you know the memory like the back of your hand, and it's easy peasy. So take care. See you soon. Again, I hope these videos are helpful. Bye.